Hi, my name is Chinmay. Today we'll be looking at an algorithm called insertion sort. An algorithm by itself is a series of steps that a computer uses to accomplish a specific task.
My name is Carter Eggett, and what an algorithm does is it creates two separate portions, a sorted portion and an unsorted portion, based off the list of numbers that have been given to you.
Each step in the algorithm includes moving the numbers in the list from the sorted portion to the unsorted portion until the whole list is completely sorted.
We can now look at this unsorted list of numbers, and by using insertion sort, we can then sort them into the sorted portion, which as you can see, has no elements in it just yet. So we can start, and first we look at the first index of the unsorted portion, which is 4. We can automatically put 4 into the first slot of the sorted portion since no other numbers are there. Next, we'll look at 32. First, we say, is 32 greater than 4? Yes it is. So therefore, we put 32 right after 4 since there's no other numbers and since 32 is greater than 4. Next, we look at 76. We start here. Is 76 greater than 4? Yes. Is 76 greater than 32? Yes. So therefore, we place it right there since no other numbers remain. Next, we look at 81. Is 81 greater than 4? Yes. Is 81 greater than 32? Yes. Is 81 greater than 76? Yes. So therefore, we place it at the end since there are no other numbers afterwards. Next, we look at 13. Is 13 greater than 4? Yes. Is 13 greater than 32? No, it's not. So we slide over the rest of the numbers and place in 32, since 32 is greater than 4 but less than 32, therefore sorting it appropriately. Lastly, we look at 29. Is 29 greater than 4? Yes. Is 29 greater than 13? Yes. Is 29 greater than 32? No. So once again, we shift over the sorted values so that 29 is greater than 13 and less than 32. Therefore, we now have a sorted list through the use of insertion sort.
So now let's look at the best case, worst case, and the average case scenarios for runtime. We could potentially make one comparison for the second element, two comparisons for the third element, and so on. The total number of steps is the sum of integers from 1 to the length of the list minus 1. And using summations, that would equal n squared over 2 minus n over 2, and the n squared term would dominate the n term. And hence that would give us a average case, an average case scenario of thetas of n squared, which is over here. And in the best case, we'd be running insertion sort on an already sorted list. So we would just be running it on a list of n numbers, and that would be this here, right here, omegas of n. And the worst case scenario would be os of n squared, and the space complexity for insertion sort would be os of 1, which means that the algorithm requires no extra space to run.